Great. So last class, we looked at completing the square. You remember?
Yes, I remember that.
Okay. Before we do anything, let's just recap the formulas. So this is a recap, right?
Yes, sir.
Right. So recap. What is the completing the square form? As the first thing I want to start off with. F of x is equal to
It was AX, I
A
think.
open bracket, A open bracket,
X plus H
right? Close bracket,
and minus K.
squared minus,
Oh, minus K.
right?
Okay.
And let me give you a little way to remember it, right? I'm going to run through this example with you one more time, just so you can understand the general process, right, Avinash?
Yes, sir.
So I could write x squared, or I should say draw it. I could represent x squared as a square with length x. Tell me if that's true. Like if you multiply x by x, we're gonna get back,
X squared.
right? If we have four x's, and to get four x's, that would just be x plus x plus x plus x.
Yes, sir.
All right. If I wanted to represent x using a shape, I would use a rectangle, right? So I would say this is x and this is 1. Why am I saying that? Where's 1 by x?
Just X.
Right. So altogether, these will add up to what x,
4X.
right? And this is, if I want to represent 1, wouldn't 1 just be a square with lengths 1 and 1? 1 by 1 is 1, right?
Yeah.
So when you're completing the square, you are trying to rearrange shapes to make a square. Right? So Avinash, I'm going to take this square and I'm going to place it over here, right? That's what I did. Then I'm
Yeah.
going to, then you'll just have four of these rectangles. So I'm going to take two and I'm going to place them over here, right? And then I'm going to place the other two over here. So you got me so far?
Yes, sir.
All right. And then I'm going to take the one and you can put it anywhere you want. You can put it here if you want. You can put it here if you want. Doesn't matter where. All right. Now check this. Before I continue, um, for the x squared square, what was the dimension for one of the lengths?
Um, 1 on top and 1X.
No, for x squared, x squared,
X squared. Oh, X by X.
right? X by x, right? X by x. So tell me, what would the dimension for this be on top,
That the red line will be just be X.
right? And what would the dimension for this be on top?
1.
1. And what would the dimension for this be on top,
1.
right? So we have x plus 1 plus 1. What would that be?
Um, I want to say, 2X.
2x.
I'm not sure.
You can figure this out. Come on, you can figure this out. X plus 1 plus 1. You can do it. You can do it. Figure it out. Figure it out. I know you can do this.
X plus 2. I'm not sure, sir.
Yes, it's x plus 2. Why are you not sure? Watch. Where's 1 plus
Uh,
1? Where's 1 plus 1?
2.
Right, x
2.
plus 2. Don't overthink it. It's simple. Right. So this would be x plus 2. And notice this would also be
X plus 2.
right. So Avinash, notice something. We created a what shape? What kind of shape is this?
A square.
Okay, it's a square. So what would the area of the square be?
Um, everything by red, so X squared plus 4. I don't know.
No, no, not x squared plus 4. It would be x plus 2 by x.
Oh, plus
Remember,
2.
Okay,
That's right.
remember, when you're expanding things like that, you need to expand it like that. You can't say x squared plus 4. No, you cannot do that. Right? You need to expand it out. Long story short, Avinash, that would be x plus 2 squared. Because x
Yes,
plus 2 by x plus 2 is x plus 2 squared, yeah?
yes, sir, yeah.
But tell me something. Do we have a complete square or are we missing some things?
Missing 3 at the bottom.
Right. So our what we have here is an imperfect square. So do you understand, Avinash, that x plus 2 squared will be for the entire thing?
Yes, sir.
But we don't have the entire thing. We are actually missing 3. So we have to subtract 3 from this entire thing. And that would leave us with what we actually had, which is x squared, x, and 1. So in a completely square form, you will have ax plus h squared, right? And then minus something or plus something to make up for the blocks it was missing or the extra
So if
blocks.
you have okay, so if you have like an extra block sticking out, you count that one when you put +1.
Yeah. So that is why you would see ax plus h squared minus k. Tell me if you understand that.
Yes, sir. So if you have a plus, then will it be plus k?
Wait, say that again?
Like if you had an extra one, then will it be plus k?
Mm, it would, I'm pretty sure we did an example where that was the
Like,
case. Oh, and by the way, is ax plus h squared plus k. Um,
but
I'll tell you
ah,
something, right, Avinash? Sometimes it would have, okay, sometimes it would have negative values. And so, like, watch. What if you had -1 here? Then, depending on the question, things would change drastically. But the general gist of it is that no matter what, you would always have to add or minus some blocks to make the perfect square.
ah,
Right. So, ax plus h squared plus k. Remember that, right? This
yes, sir.
is the formula here. Next thing, you need to know what h is. Do you remember the formula for h?
Wasn't age a over b or something else I was thinking?
No, it was b over 2a.
Ah, b over 2a. Damn,
And what was k?
that was ab.
No, Serena, I want to tell us what k was.
K was C minus B squared over 4A.
Ah,
Yeah, c minus b squared over 4a. Right, Avinash, please remember these formulas. Right, so we have h and we have k. Now, Avinash, do you remember how we would figure out which point is the minimum or the maximum point? Maximum turning point?
the point where the we had reached the furthest it could go before turning back.
Okay, you need to be, I wasn't, you're correct, right? But I'm talking about in terms of h and k. And if we're talking about h and k, it'll be minus h, comma, k. Right, so these were the main things you needed to know. You needed to know how to find for h, how to find for k, then write that in this form, and then you needed to be able to find the minimum or the maximum turning point. These were the things you needed to know. So like write it down fast. You should have it in your book, right?
Yeah, I have it. I was gonna
Okay.
make a new note real quick.
All right. If you have it in the book, we could jump straight into our question, right? Straight into our question. So I would like you to read part B1.
Express the quadratic function f of x equals 3x squared plus 6x minus 2 in the form a a bracket x plus age bracket square plus k, where a, age, and k are constants.
All right. You're not seeing the screen. Wait, sir. Let me just fix that. Not sure why that happened. All right. As soon as you see the screen, you let me know, right? Okay. All right. Are you seeing the screen?
Yes, sir.
Okay, cool. All right. So Avinash, first things first, what do we call this type of expression?
A quadratic. Oh, well,
Quadratic, right? Great. It's a quadratic. Now, all quadratics would be uniform. Ax squared. Continue. Ax squared
plus bx minus c, or was it plus c?
plus c. It's
Okay,
always
right.
positive. Always positive. Never negative.
Plus,
Always positive. Remember that. Always positive, right? So, if this is the case, Avinash, I'd like you to tell me what A, B, and C would be. What would A be?
3,
B would be equal to
6,
C.
and minus 2.
Right. Great. What did they want us to find for? Um, they wanted us to write this in the form ax plus h squared plus k. So if that's the case, Avinash, we would need to figure out what a is and what else. What are the other two things I need to find for?
H and k.
Right. Is there a formula we could use to find for h and k?
Yeah,
Yeah.
yeah,
What's the formula for
yeah,
h?
yeah. That was, I don't know how, right? That was b over a.
No, b over 2a.
Yeah, b over 2, remember.
And what's the
And
formula for k?
was c minus b squared over 4a.
Nice. All right. So what is b?
B was 6,
Right? What was a?
3.
Right. So on top is going to be 6, and then the denominator is going to be 2 by 3. What is 2 by 3?
6,
What is 6 over 6?
3, 2,
1.
1.
6 over 6 one time.
Right. I was thinking about it. I was thinking about the like one more time.
Um, Next one. Time for you to redeem this up. Okay. What is C? Come on, what is C?
C was negative 2.
Right? Minus B squared. What is B?
6,
Right? So I'm going to write 6 squared all over 4 by A. What's A?
3.
Right. So we're going to take our time with this, right? So I'm going to write back the minus 2. Going to put the minus sign here again. What is 6 squared?
12.
I'll give you some time to correct yourself. It's not 12.
6 by 6.
Yeah.
That was. So my brain thing got blank. Give me a second.
All right. 6 by 6 is 36.
Yeah, 36.
And what's 4 by 3?
4 by 3 was
All right. 4 by 3 is 12. Right? So we're going to end up with minus 2. And what is 36 over 12? What is 12 and 36?
4
No, 12 is going to 36 three times.
2 times. Okay.
Right? What's minus 2 minus 3?
Minus 1. No, yeah,
No, minus 5.
minus 1.
If you take 2,
And you take 3, right? 3 minus 5.
then altogether you take 5. So minus 5. Right.
Right.
So we have A we have h, we have k. That being said, I could write it in the form that we want now. Remember, a complete any square form does look like this. It is a open bracket, what you tell me?
Open bracket, x plus age, close brackets, squared, plus k.
Great. I would like you to tell me what a is.
A was 3.
It was 3, yeah? What was h?
Well, 6.
I'll give you some time to correct.
1.
What was h?
1.
Right, so plus 1 squared, all right, and then plus k. So you're gonna put k now. What was k?
Minus 5.
Now this is confused a lot of students. Watch. I'm gonna put back the plus sign, and in brackets, I'm gonna put what k was. Now k was minus 5. K was minus 5. Right? I'm gonna write back this now. So it'll be 3x plus 1 squared. And was a positive and a negative?
A negative.
Right? So a positive and negative. So that'll be negative 5. Bam. That's it. Right? So run through it and make sure you understand the working. Make sure you understand that. Right. I see we have a new person here. Caleb. How are you? Good evening. I should say these classes are very interactive. You're not gonna get away. You're gonna...
Hi, good evening.
Good evening. How are you?
Hi, good.
That's great. Selma, what is your take of art maths? Yeah, you like it, you hate it, you feel into
I like it. It's just some of the topics I doesn't understand when my teacher teach it.
Okay, well, here what, right? If you feeling
Yeah.
confused at any point in time, stop, man.
Yeah.
Right?
Okay.
We're all chilling
Yeah.
in class, and you could tell me anything. You could tell me 1 plus 1 and I might. You could tell me 1 plus 1 is 3 and I mightn't judge you. I say might. I say mightn't. It depends on my mood. Depends on my mood. Like today, I cannot stress it out. So I might judge you a little bit. But under
Okay.
normal circumstances, once you okay, if I ask you a question and you tell me
Yeah.
and you try, I wouldn't dig no horrors. But if you use AI or like you guess,
Yeah.
then I'll have a problem. But like anytime I ask you a question, give me like an honest answer and think about it, and we'll be good. Right? Don't be scared to answer. If it's almost something wrong, that's fine. Everybody will learn from that. If it's almost the correct answer, that's great. So tell me, Caleb, did you do complete any square in school as yet?
Yeah.
Yeah? Okay. So the next question I'll do with you, right? I'll do the next question with you. But is there anything that you didn't understand here? Be honest with me, did you learn these formulas for H and K in school?
For K, I did. K is 4AC take away B squared over 4A.
All right, that's not a problem. Let me show you something. So 4AC minus B squared over 4A. And as we learn,
Yeah.
check this, right? Check this. If I have 5, check this, right? If I had 5 over 3 minus 2 over 3, how would I write that?
3 over 3.
Right. And if you were to write the full working, wouldn't you say 5 minus 2 over 3?
Yeah.
Okay, and then you would just simplify that and you would say 3 over 3, which is just equal to 1, and
Yeah.
okay, check this. So if you notice over here, right, we have 2 terms on top, right, being split over 4A. So how could I split that up? So I would like you to look at this and look at this example here. And I want you to think in reverse. I could take 5 minus 2 over 3 and convert it to 5 over 3 minus 2 over 3. So we think it's another way I could write that.
Can you repeat, please?
All right. So you see this fraction over here?
Yeah.
Is there any other way I could write this fraction?
Um.
and this is my hint. I could write 5 over 3 minus 2 over 3 as 5 minus 2 over 3, and vice versa. If I had this, I could write it as 5 over 3 minus 2 over 3. So think to yourself, is there another way I could write that fraction, like separately?
I would say it there is, but
There
I
is.
don't. Yeah.
Well, you know how to do it. Trust me, you know how to do it. Check this. Let's look at this example we had earlier, right?
Yeah.
And to understand this, 5 over 3 minus 2 over 3, that is 5 minus 2 over 3. Like, you understand that?
Yeah.
Okay. What if I had give you 7 minus 2 over 3? You think you could split that up?
Yeah. 5/3.
Okay. That's not what I mean. You're correct, right? But that's not what I mean. I would like you to split it up like this for me.
Oh,
If you could split it up.
7/3 take away 2/3.
Great. So you see how you do that? I want you to apply that same logic over here now. That same logic. Do that same thing over here.
Um.
Now I know it has some letters. Looking a little intimidating. Same procedure, right? Watch. Like we
Yeah.
have 7 is one term, right? So we write 7 over 3.
Yeah.
4AC is one term. So I'm going to write 4AC over what?
Over 4.
Right? What next?
Take away b squared over 4.
Great. Are you seeing anything I could cancel off over there?
Yeah. The is
Yeah, the A's cancel off. What else could cancel off?
the 4's
That would leave me with what?
c take away b squared over 4. Okay.
Aha.
Yeah.
So is the same thing?
Yeah.
It's the exact same thing. Some schools just teach this. They teach this instead of this, which is fine, whichever one you remember, right? But I just want you to know it's the same thing and both are equally correct,
Okay.
right? Did you know that before? Like, did you know you could play with your fractions like that? Like split it up and simplify?
No.
I mean, you'd have learned that in Standard 5, right? But now it had letters and all kind of things.
Yeah.
You're probably thinking you can't do it, but it's the same process. Nothing ever changed, right? It is the same concept like this. You're learning Standard 5.
Okay.
All right. So now that you understand that, you're okay with the formula for H, and you learned it as B over 2A as well?
Yeah.
Okay, great. So B over 2A is H, and C minus B squared over 4A is K. All right.
Okay.
So you know how to figure out what A, B, and C is?
Yeah.
All right. From there, you just plug in everything in. Right? Avinash, you okay with the formulas?
Yes, sir. I write in it. I like I write in them long them.
All right.
Remember them.
Lock them formulas in, please. Please.
So yeah, I just don't know how to keep them, like memorize them easier or like memorize them on the whole.
The only thing I can tell you is to derive it. And the derivation for real long. Yeah.
All right.
I would just tell you to try. Here, what if you have a Casio, what you do, the Casio calculator gives you the answer. If Wait, Caleb, do you have a Casio or Sharp?
Casio.
Ah, boy, Serena. Avinash, you have a Casio man here. Big up Caleb. Right? Serena, I will organize with you, right? You go let me know what day I could meet you, so I could give you the Casio calculator.
Okay.
You go let me know, right?
Okay. Thank you.
Right. I'm gonna wear a Santa outfit. I'll be in real. Serena,
Like a full Santa suit.
say that again?
A full Santa suit.
Maybe not. You go see. You go see. That'll be real funny, right? You should
Yeah.
catch me wearing a whole Santa suit just to give you a Casio calculator. Yeah, well, I wouldn't put it past myself. I would do some weird stuff. I would do that.
So
right? But
if you do that though,
yeah,
you could suggest for your promotions, holiday promotions.
yes, yes. Serena, would you be okay with taking a picture?
Yeah, sure.
All right, Serena. Serena will blow up on social media. All right. So we are done with this example, right? Great. So anytime they ask you to put it in a complete in square form, they are talking about ax plus h squared plus k, right? To find for h, you use this formula. To find for k, you use this formula. Once you do that, you just plug it in into the form, and that's it. Simple as that, right? The next part, hence or otherwise state the minimum value of f of x is equal to 3x squared plus 6x minus 2. So Avinash, do you remember how that does go?
Nah, so my brain real blank today.
All right. Um, Avinash, do you remember how to figure out if a graph would be a maximum or minimum?
As if it was positive, it was was it maximum?
No, okay.
I don't
Avinash,
know.
if you're positive, right? Are you smiling or are you frowning?
Smiling.
Right.
That
That
was
would
a minimum, right?
right. And if you're negative, you're sad, so it'll be a maximum. If you understand that.
Yes, right.
If we look at our function that was given to us, is the coefficient of x squared positive or negative?
Positive.
So that means our graph would look like a happy face. And if it's a happy face, that would mean that it's a maximum or minimum,
Minimum.
right? Minimum. Great. So I just want to remind you all, why do we need to find h and k? Well, it's very handy because it allows us to figure out, in this case, the minimum point. Caleb, do you know that if a is positive, then the general shape of the graph would be a minimum? Do you know
Yes,
that?
sir.
Okay, good. So our graph is clearly a minimum. So we'll have a minimum turning point. And our minimum turning point would be given by what, Avinash? Do you remember? Do you remember what the minimum turning point would be given by?
So I was in negative, I think. I can't remember. Trying to.
Okay, lock this in now. Negative h, comma k.
So I was right about the negative part.
Right? So negative h, comma k. So our graph, the lowest point our graph is going to go down to would be negative h. H is 1, so that's going to be negative 1, comma k. Now k is negative 5. So our graph is going to go down to -1, -5. So let me just do a sketch and show you what that would look like. So we're going to have a graph here. Now I just doing a sketch. It's a really, really bad sketch. I just winging it here. At this point, I just winging it. So like, so tell me, Caleb, if this is the minimum turning point, what will the x value for the minimum turning point be? Tell me, Caleb, what will the x value for this point be? Do you know?
Nah.
Right. Caleb, a point is made up of a what and a what value? All points are made up of a what and a what value? I was
Nah, I
talking
don't.
a x and a,
It's A.
say that again,
A.
x and a y value.
Right.
Okay, just to jog your memory, what axis is this?
The y-axis.
All right, what axis is this?
X.
All right, so all points, and by the way, I call this the Cartesian plane. All points are made up of an x value and a y value. Right, the x value comes first and the y value comes after. So x would be -1 and y would be -5. Understand?
Yeah.
Okay, so Selma, Caleb, and Avinash. Serena, I know you know, right? So you could just rock back and relax. Caleb and Avinash. If our minimum point is at -1, -5, then tell me where x would be -1. Would it be -1 over here?
Yes.
Mm,
No, on the other side.
All right, on the other side. Because if you recall, this would be 0. Everything here would be
Yeah.
positive.
Positive.
Everything here would be negative.
Mm.
Right? So do you all understand that -1, and this is a rough sketch, -1 would be like somewhere over here. Yeah?
Yeah.
Okay. Avinash and Caleb, the y value is -5. So is it going to be above here or downwards?
downward.
Downward.
Great. It would be downwards. So -5, I could estimate that to be over here. Right? And this would be the minimum point. This is the minimum point. In other words, this is the lowest point. The graph is going to go. So this is a really bad sketch, not a real bad sketch, but this is what going on. What's going on? So the original question was to state the minimum value. The minimum value. So Caleb, what's the lowest value the graph is going down to?
-5.
Great. So the answer for that question was just the k value, right? So minimum value. So minimum value is always equal to the k value, right? And as you can see, this is the k value. Now, I probably confused some already there because I just said x and y. Caleb, did I confuse you? Like, be honest with me. Like, be real honest.
Nasty.
Right. Do you understand that the point is given by -h, k?
Yeah.
And we found k to be -5, correct?
Yes.
Great. And do you also understand that all points has an x value and a y value?
Yeah.
Right. So it was x is equal to -1, so -1 here, and it was y is equal to -5. Now, as you can see, the minimum value was -5, which corresponds to the k value. Right? So the minimum value or the maximum value is always given by k. Avinash, can you see for yourself that the lowest value the graph going down to is -5?
Yes, sir.
Great. So the answer for this is just -5, which is key. So you didn't have to do all of that. Anytime they ask you for the minimum or the maximum, it's just equal to k. Hopefully remember that. It's literally just k. Let's move on. All right. Part 3. State the equation of the axis of symmetry of the function. So I'm going to take all it back to standard 5 here. If I were to draw a heart, right, guys? I want you to tell me, where would the line of symmetry be?
In the middle.
It would be in the middle, right?
Yes.
Avinash, that's correct, right? The line of symmetry would cut the shape into mirrored halves.
Yes, sir.
Okay. So what would be the line of symmetry for this parabola, a curve? The fancy name for the curve is a parabola. Tell me, Avinash.
-1, -5.
That's no, not -1. -1, -5 is the minimum point.
Okay.
Okay. Tell me, Avinash. The line of symmetry and the axis of symmetry is literally a line. Is a line that will be cutting the shape. So if we have this shape, how would I need to cut it to divide it into 2 mirrored halves?
Right down the middle.
Right down the middle, right? So if I do that, I'm going to get a line passing through what?
-1.
Exactly. So that line would be, let me see if I can figure out the equation for that line. See if I can figure it out.
The
-0.
I had two things. I had -1, 0, which is wrong because
Okay.
we want the equation. An equation means I have, you need to have an equal sign. So something needs to be equal to something, right? Caleb, you said something?
I was gonna say is equal to the h value. Well, h, yeah.
Okay, you're close, right? So Avinash, this line is passing through -1, and -1 is on the what axis?
The x-axis.
So put 2 and 2 together. There must be an equal sign, and I'm telling you, -1 will come on the right-hand side.
So x equals -1.
Yes, because it's passing through -1 on the x-axis. Caleb, does that make sense?
Yes, sir.
Yeah, sure.
Yeah.
Okay, so anytime they ask you for the equation of the axis of symmetry, it is given by -h, always, right? Right, so, right, axis of symmetry, the axis of symmetry would always be given by -h. So you would say x is equal to -h. So our answer for this question was x is equal to -1. You need to put the x part because Caleb, when you hear equation and you think of equal, equation, equal, yeah or no?
Yes, sir.
When you think of the word equation, doesn't equal come to mind?
Yes.
Yeah, so when they ask you for the axis of symmetry, they're talking about an equation, right? The line passes through -1 on the x-axis, hence you would say x is equal to -h. Now, -h in this question would be -1 because we found h to be 1, so -h would be -1. And as you can see from the graph, if you draw a line passing through the middle, you'll see that the line passes through -1, which we know is -h. Is everybody with me so far?
Yes, sir.
Okay, let's move on then. Part 4, sketch the graph of y is equal to 3x squared plus 6x minus 2, showing on your graph the intercept on the y-axis and the coordinates of the minimum point. All right. So Serena, I want you to help me with this question, right? So they want us to figure out the intercept on the y-axis, right? Intercept on the y-axis. So Serena, if a line or a graph cuts the y-axis at that point, what do we know x is equal to?
X would be equal to 0.
Great. So if x is equal to 0, is it possible for me to figure out what the y value would be?
Yes.
All I would have to do is take x is equal to 0 and
Plug it into the function given.
exactly. So f of x was equal to 3x squared, etc., etc. Anywhere you see x, you're going to replace it with 0. So we're going to write 3 by 0 squared plus 6 by 0 minus 2. And Serena, what's that going to work out to be?
-2.
Right, -2. So, Caleb, I want you to be real honest with me. Does this confuse the heck out of you? You can be honest with me.
Yes, yes, sir.
We paying attention.
Yeah. Yes, sir.
All right, I want you to tell me. Does this confuse you?
Oh, no.
Okay, so we're gonna test you, right? When you hear intercept on the y-axis, do you know what that means?
X.
Okay, I'm gonna draw a diagram, right? I want you to tell me where the y where it cuts the y-axis. Where does it cut the y-axis? At 1, 2, or 3?
at hold on.
Say that again.
1.
Oh. Mm-mm. Okay, what axis is this?
The y-axis.
Okay, so where does the curve cut the y-axis? Does it
2.
exactly at 2? Yeah, at 2. Now, I want you to understand something. If you are on the y-axis, right? If you are on the y-axis, that means the x value is 0. I could give you a quick example. You think you could read off this point for me?
Like 0,5, like xy.
Yeah, exactly. It's almost 0,5, right?
Yes, sir.
Right, because if you're on the y-axis, did you move left or right?
No,
No, you just move in one direction. You can either move in
up
one
and down.
exactly. So if x corresponds to left or right, and you didn't move left or right, that would be 0. But you
Yes,
did
sir.
5 up, so that would be 0,5. You notice that the x value was what?
0.
Exactly. So what I'm saying is, if you are cutting the y-axis, then the x value is going to be equal to 0.
Yes.
And with that information, we could plug 0 into the function, right? The 3x squared, and you'll get the y value. So when x is equal to 0, right? The y value is -2. Did I confuse you?
Nah, sir.
All right, Avinash, be really honest with me. Did I confuse you?
Nah, sir.
Okay. Serena, I'm not even gonna ask you. I know you're okay. Aren't you okay with this? Like this, you're all good with this, right?
Yes, sir.
Okay, good. All right, next part. They want us to put the coordinates at the minimum point. Did we find that already, guys? The coordinates at the minimum point. Did we find that already?
Yes, sir.
What was the coordinates at the minimum point?
-5.
-5.
-1, -5.
Yes. Caleb, anytime I ask you for a coordinate or a point, it must have an x value and a y value. So that would be the -1, -5. What you just told me was the minimum value, which is just
Yes.
how the graph going down to.
Okay.
All right. When I finish, I'll just clean it up and make the notes a little more legible. All right. Okay, so let's put everything on the graph now. All right, so we're gonna draw back the graph from scratch here to make sure you all understand everything. So, Caleb, what axis is this?
Y-axis.
Okay, what axis is this?
X-axis.
All right, what would I call this point?
X.
X. Nah.
With
Starts with O. The rest of you guys could jump in, eh? I like a jump in too. O.
The origin.
Yeah, is the origin. Because it's the starting point. It's the starting point, right? Starting point. This is the origin. Great. Now, they want us to include the y-intercept and the minimum point. Let's put down the minimum point first. Remember, guys, the first value is the x value. The second value is the y value. So, Zachary, I see you just joined. So tell me, Zachary, if we want to put the minimum point, I would need to locate x is equal to -1. Now, I'm just doing a sketch. So tell me, Zachary, would -1 be over here or over here? To the left or to the right?
The left, sir.
To the left. So we could say that this is -1. And if we're saying y is -5, would that be over here or would that be over here? Up or down?
On the down, sir.
Exactly, it will be down. So that'll be minus 5 over here, right? And then I'll put the point. So this would be the minimum point, right? And the minimum point is minus 1 comma minus 5. And it represents the lowest point that the graph is going down to. Now, guys, just remind me, the coefficient of x squared, was it positive or was it negative in this question?
Positive.
Was positive. If it's positive, you know it's a smiley face. And so this is the general shape of a graph, minimum graph. So going to draw my graph. And before I draw my graph, right? Telma, Caleb, what did we find the y-intercept to be? Where is the graph cutting the y-axis at?
-2.
Great, -2. Tell me, right, Caleb, if we're saying
Yes.
y is equal to -2, would that be found over here? Or would that be found over here? 1 or 2?
Only down.
Down.
2.
Right.
Yes.
Right. Would I put it after -5? Like, would I put -2 over here? Or would I put
No, sir. Yeah, closer to the origin.
exactly? Right? Great. All this song and like all have all their head on their shoulders. That's good. That's good. All right. So now I'm going to draw my graph. And this is what it's gonna look like. All right, don't laugh at me. I try nothing here. Okay, I'll understand that.
Yes, sir.
Okay, good. Avinash, tell me, you understand that?
Yes, sir.
Right. So we know that the graph has to cut the y-axis at -2, and we know that the minimum point is -1 comma -5. And again, guys, if they ask you for the axis of symmetry, that would just be the line passing through the -1. So that'll be x is equal to -1. All right, but that's about it. And 4 marks for that? That's crazy. That's really crazy. That's a nice question. So tell me, guys, I want some time to copy down this example.
Yes, sir.
Okay, I'll give all this some time. Zachary, how are exams going? And if you start exams yet.
So my exams finished today.
Okay, so you rock back, you're relaxing.
Yes, sir. Yes, sir.
Right. Yeah, you're going to watch the new season of Stranger Things.
Yeah.
I still didn't get around to watching that. You go tell me how it go.
Yes, sir. For sure.
All right. Okay, so Serena, you have some competition. Zachary might get some competition. I just saying, might. All right. Serena, how do you feel about competition? Do you welcome it?
Yeah.
Okay. Nice.
So she mightn't get no competition. Maths is not a strong subject of mine.
Okay. Well, Serena is a art maths boss. And a maths boss, to say the least, like Sherelle Bad. You sounding like you have it, right? Avinash, I know you just struggle with the maths, right? Don't feel shame. You'll get it. Caleb, I only know you for a little while. It sounds like you're interested in it, but you still have some bumps to like go over. Yeah. But just keep up, Caleb, and you'll get really good at it. It's not that hard. Trust me, you'll get it. Right? Um, can you all see everything that's on the screen? Or you need me to zoom up a little bit?
I finished, but so
Zoom in or like let me know what to do. Make sure I copy down, eh? Send me a picture if you could. Send me a picture of the notes. I want to see how well you're writing this thing down. Also, I want to see all your handwriting. All right. So when I'm ready, tell me, I'm going to move on. Matter of
Yes,
fact, as a matter of fact, I could even give Ollie a question. Caleb, I need to stress on something, right? Caleb, you see all of this? This was optional. You didn't need to put that. I just put that there to explain the minimum value, right? But
Yes, sir.
for that question, this is all you needed to write. It could have said minimum
Oh,
value is equal to K, and that'll be equal
yes,
to
sir.
-5. But I drew the graph. So you could have see that it going down to -5 now. You could have see it. But
Yes, sir.
this is all you need to know. Minimum value is equal to K, right? Axis of symmetry would be x is equal to -h, x is equal to -1. But I would always implore you guys to do a sketch. Do a sketch, see how the graph looking, and then move on. So yeah, when I'm ready, tell me, I'll go give all a question. Test all your skills.
Excuse sir, I finished.
Okay, great. Serena, I feel like you finished a long time. I see you send me some homework. I forget I even give all the homework. But I think I did.
This question was the homework, so I already have everything.
Oh, that question was the homework.
Yeah, and you did challenge me to draw the
Oh yeah, I did challenge you to try to finish it.
every time I feel like I was getting close to it, something just wasn't adding up. So I kinda gave up.
Okay, you wanna attempt it together?
Yeah.
Okay, we will attempt it together. All right. I didn't do it. I didn't do the diagram for this one, so it'll be my first time doing it as well. Right? But that's even better. You'll get to see me. Maybe you want to see me struggle, but we go see. We go see. I don't think I will struggle. We'll see. All right. Let's move on, right? So I would have showed Abinash and Serena this last class. I would have showed them what completing the square actually is. Zachary, I don't know if you know. Do you know how to do completing the square graphically?
Not seen it graphically.
Okay, well, Caleb and Zachary, are going to learn something new today. Like, are going to see why they just call it completing the square. Now, this is a kind of hard example to do it with, but we will see. We will see how this going to go anyways, right? So check this. So Serena, I want you to unmute, and we're going to try to attack this thing together. All right, so f of x is equal to 3x squared. I'm going to use different colors so as to not confuse anybody. So f of x will be equal to 3x squared, right? Then plus 6x, right? Then minus 2. Okay. All right. So Serena, let me guess, the minus 2 confuse you.
I think so, yeah.
Okay. And let's put the answer down to the side. Let's just put the answer down to the side. This is the answer. This is the answer we're going for. All right, so Serena, let's go. So for most of you, for you guys in class, right, that don't know, you could actually write algebraic expressions as shapes. Let me explain. So tell me something, Serena. If you have 3x squared, that means in another way to write that would be x squared plus x squared plus x squared.
Yes, sir.
Okay, so another way I could write f of x is I could write it as this. So I could say, I could write it as a square, right? Okay, but our shape had how much x squareds in it?
3.
Had 3, right? So plus, so I'm going to duplicate this thing 3 times. Okay, Zachary, tell me if I confuse you real about there. Like, tell me if you're real get confused.
No, sir.
Okay, so Zachary, you understand that all I did, right? I just represent 3x squared as a square, right? And I said that the length was x and x. And obviously, if you find the area that way, it would be, where's x by x?
X squared, sir.
All right, so if you combine this, the area going to be 3x squared.
Yes, sir.
Kilo, be with me?
Yes, sir.
Okay. Avinash, what about you?
Yes, sir.
Okay, cool. So I'm just going to rearrange this thing. I can ask you for a moment there. Yeah. Advanced physics. Let me go back to some simpler stuff. Right? Then I have 6x. That's gonna be quite a lot, but let me do it anyways. So Serena, 6x. That would be how much? That would be how much x is.
6x's.
Wait, I'm gonna raise my volume. Tell me, Serena, how much would 6x's be?
It would be
6 x's, right? So entry could represent 1x as a rectangle with length x here and length 1 here.
Yes, sir.
All right. And I'm going to duplicate this thing 6 times. Lord have mercy. All right. So Avinash, remember when you ask more graph and if it have a negative, you go see.
Yes.
Now I myself never do the diagram for like one with negatives, so we go see how that will go. I trust in my mathematical intuition. It will work out. It will work out. All right.
Dory says a genius when it comes to them things.
Say that again.
He's a genius when it comes to them things.
Give him too much credit. Okay.
Hyping you up, sir.
All right. So here what we're gonna do, right? Let me forget about our -2 for now, and let's just try to rearrange. You see all these shapes here? Think of them as Lego blocks. And our goal is to take this and make it look like a square. Okay, that's what we want to do. So Serena, I'm going to take this block. I'm going to take this block, put it down over here. I'm going to take another one of those blocks. Going to put it down over here. Okay, I'm going to take another block and I'm going to put it down over here. All right. Do you guys understand what I did so far?
Yes, sir.
Okay, so
Yes, sir.
I'll understand. If you think about this as Lego blocks, the only thing I do, right, I just take these three and I'll organize it like this. But it's still 3x squared. It's literally still 3x squared. Okay. So I trust are we on the same page there? All right. Next thing. What we could potentially do, we could take 3 of these. So let me think. We'll probably take 3 of these. Right. And then we have 3 more, so I'm gonna take those 3 more and I'm gonna put it over here. All right. So Serena, did we successfully come up with a square? Serena?
Not a completed one.
Not completed one, right? But let's just say I did complete it. If I did complete it though, remember this length over here, what would our length be?
X.
This would be x. This would be x, right? This would be 1. This would be 1. This would be 1. So this dimension would be what?
2x plus 3.
This dimension would be 2x plus 3. And this dimension would be 2x plus 3 as well, correct?
Yes, sir.
But I think you could clearly see we don't have a perfect square. Let's check out something, Serena. And by the way, this wouldn't give you the exact same solution. It wouldn't give you the exact same solution, but it will work out in the end. So let's continue, right, Serena? And the next thing, we had -2. So let me just keep that -2 in mind. So Serena, let's check out what the area is over here. Because Enchi would agree that the area that we're missing, we would have to subtract it from 2x plus 3 squared.
Yes, sir.
Great. So far, it will be 2x plus 3 squared. If I'm losing the rest of you guys, I will explain it at the end, right? Don't worry. So Serena, let's find the area for the missing portion and the inside. What would this area on the inside here be?
X plus 3.
This would be x plus 3. And what would the dimension here be?
It would also be X plus 3.
So we are actually missing an area of
X plus 3 squared.
right. And remember, at the start, we had -2. So I'm going to put that back. Let me see if this works out. I'm really curious to see if this will work out. If I expand this out, I would get back 4x squared, right? Plus 12x plus 9. Then I'll get minus x. I'm just doing this quick in my head, right? And I'll be minus 6x, right? And I'll be minus 9 minus 2. So Serena, let's see if this would work out, right? So if you combine the x squared terms, you would get 3x squared. If you combine the x terms, you have 12x and minus 6x. What would that be?
It would be positive 6x.
And you have positive 9 minus 2. So that'll be minus 2. So this expression is correct. You agree?
Yes, sir.
It is correct, but it's not in the complete unique square form that we want. So, you know what that means, Serena? That means that there's some other way we could represent this thing. There's some other way. There is some other way. So, Zachary, let me explain to you what happened here, right? When you're doing complete unique square graphically, sometimes you have to like change up the orientations just to make it work. But did you understand the general concept?
Yes, sir.
Okay, so Zachary, you understand that all we did was we are rearranging the elements to try to make it into a square. Now, obviously, would you say that this is a perfect square if you're missing this big chunk?
No, sir.
No, it's not a perfect square, right? Caleb, this looking like a perfect whole square? Or does it look like it's missing part over here?
Missing party.
It's missing parts. So if you find the area for the whole thing, the entire thing, that's going to be 2x plus 3 by 2x plus 3, which is 2x plus 3 squared. But we just agreed that we are missing this whole chunk. So we had to find the area for that chunk and then take it away from the big area. So that'll be minus x plus 3 squared. And don't forget, at the start, we had -2. So I'll put back the -2. You could probably see with your own eyes that this does not look like this. So while this expression is correct and it would give you back the original thing, it's not exactly what we want. So we need to rethink what we did. All right, so Serena, ready for round 2?
Sure.
Okay, so our goal here is to rearrange these things into the ideal form that we want. Okay, so let me think. What's another way we could rearrange this thing? What if I do this? If I do that. I'm thinking. It's a tricky one. Are you guys seeing any other way we could rearrange this diagram to come up with a square? If you are seeing a way, tell me. Just by looking at it, I'm not seeing any other ways, like logically. What if let me check what our prior example that we did. Okay.
So,
Tell me.
well, if it was to put um the 2x, the third cube to the bottom next to the other two and put the all the purple squares to the but no. Wait.
Okay, so tell me to do this.
No, the one to the bottom put the one on, yeah, that one next to, but no, that one. No, next to the one on top.
Next to the one on top. Over here.
Yeah.
That's
Yeah.
it. Okay, and what next?
The one next is for all of them underneath.
Okay, let's see if that's gonna work. That's it. Okay, let's see if it's going to work. This is what you tell them what to do.
But I don't think I'll it will work, but it was supposed to be put them next to each other.
Well, let me see if it will work now. Let me see. Now, there's an easy criteria to see if it's going to work. Let me show you what I mean. According to how we rearrange this thing here, right? I want you to tell me, what would this dimension over here be?
3x.
That would be 3x. What would this dimension be? Let's see.
1x plus 6.
Wait, let's take your time. So this dimension over here would be x. Remember, this
X,
would
yeah.
be 1 by x, so this would also be x, and this would also be x. So,
3x.
okay, so you're not wrong. You're not wrong. That would form a square. Excellent. Big up you. Okay, now, that's, if you were to find the area of this entire square we just formed, so this entire area, that entire area would be 3x by 3x, you agree?
Yes.
So that'll be 3x squared. All right. Now, this still wouldn't give you the exact answer you want. Still wouldn't give you the exact answer, but your concept was right. And if you notice, we are missing this area over here. And that area would be, well, it would actually be, this will be kind of tricky, right? If this is x, then this area over here, that would actually be, that would be x minus 1. And this would be x. So this area on top here would be 2x plus 1. And that would complicate things pretty fast. Let me explain that one more time, right, Caleb? So don't confuse you. This is a square, right? So you understand all the sides are x. Yeah?
Yeah.
Okay. So if this dimension, if this length is x, right? And
Yes, sir.
if this length is 1, then the other part here will be what? See if you can figure it out. If x is the whole length and 1 is piece of x, what would the remaining length be?
1.
Now, if I said that this was if I said this was 5 centimeters, right, and this was 1 centimeter, how would you find the remaining piece?
5 take away 1.
Exactly. So wouldn't you just say x take away 1?
Yes, sir.
Because x is the whole thing, and 1, right? So x is the whole thing, and this small piece over here is 1. So this missing piece here would be x minus 1, and this piece over here would be x. If you add that together, right, that's going to be 2x minus 1. And as for this, we know that this is x and this is x, so that's going to be 2x. Now, everything it told me was 100% correct, but again, that's not going to get it in this form.
Yes, sir.
Yeah. It's very interesting. I wonder if there's some cases where you just can't do the diagram for. I highly doubt that. I'm sure there's a way to do this. I'm just not seeing it. Sure there's a way.
So,
Come on.
if you take two of the ones and put them like originally next to, like on top, like, yeah, 2 right there, just like that. Then you put 2 on this side at the bottom, by the bottom one. And then you just put 2 on the side right in the middle.
I mean, nothing is wrong with that. What you said makes 100% sense. Yeah, that's fine. That's fine. So let's run through that one more time. So you said, oh, this, right? Yeah, that makes sense. That does make sense. So we form a imperfect shape. Cool. Right? So what would this dimension be?
2x plus 2.
Yeah, that would be 2x plus 2. And this would be
2x plus 2 as well.
yeah, 2x plus 2 as well. Right? But again, you're not going to get it in the form they want. So here what? I will do more research on this and get back to this, right? Because all the examples we looked at last class was when we just had 1x squared, right? There's one more suggestion I have, right? There's one other thing I could think of. One more thing. Serena, and this is just going off on a wild goose chase, right? I think it will make sense. Serena, notice we have 3 by x plus 1 squared.
Yes, sir.
Okay, so I'm going to I'm going to speculate here. But if you were to divide this area by 3, if you were to divide that area by 3, hypothetically speaking, wouldn't you end up with x squared plus 2x minus 2 over 3 if you were to divide the area by 3?
Yes, I was thinking to do that, but I didn't try it.
Well, you want to try it now and see if it will work?
Sure.
Let me try that thing. Again, I'm not sure how correct this is, right? But we will see. So x squared, that would just be 1 square, right? That'll be 1 square. 2 x's, if it's 2 x's, that would be 1 here and 1 over here. Okay. Right? But you probably realize that does not form. Actually, it does, but so you're not just seeing x here. This will be x as we 1 and be x plus 1. See that?
Yes, sir.
Okay, so let me see how this is gonna work out, right? We are actually missing a small piece. But let's calculate the dimensions first. This dimension would be what?
X plus 1,
And this dimension will be what?
x plus 1.
Okay. Okay. And let's figure out how much we are missing. Right? This, what is this dimension?
1,
And this dimension here?
1,
So we are actually missing one.
1.
Right, so another way to write that would be f of x is equal to x plus 1 squared, but we are missing 1. And remember, at the start, it was minus 2 over 3. So you're missing that as well. Let's see what we're going to get. So I'm going to write back x plus 1 squared. What is minus 1? Minus 2 over 3. Your mind is going to be blown. What is that going to be?
Minus 5 over 3, sir.
Yeah, minus 5 over 3. And I just want to preface this by saying something, right? Guys, if this was the original area, right? To get this, didn't we divide the original area by 3?
Yes, sir.
Yeah. So this expression we actually have here is actually f of x divided by 3. Now, if you wanted to find the original area, right, which is just f of x, what do you think I should do throughout?
Multiply.
Okay, so Caleb, I think you have it, you know. If you have a third or something, and I want to find the original amount, what would you do?
Can you repeat, please?
I say you have it, you know. If you have a third or something, and you want to figure out how much the entire thing was, what would you multiply it by?
By 3.
Exactly. So if I multiply both sides by 3, what am I going to get? So Caleb, let's take it one step at a time, right? If I have f of x over 3 multiplied by 3, what's going to happen with these 3's?
Cancel it out.
Okay, so we're going to get back the original area, f of x. And
Yeah.
remember, and if you're doing something on one side, you need to do it everywhere. So what is x plus 1 squared by 3? How would I write that?
3x plus 1. 3. Yeah, x plus 1 squared.
All right, and now I need to ask you, what is minus 5 over 3 by 3?
Minus 5.
You don't need a calculator for that because what? Look at this, right, Caleb? Oh, what happened?
Yes.
What
Oh,
happened?
it will cancel out, sir.
Yeah, so that would just be minus 5. Is that the answer?
Yes, sir.
So you know, we crack the code, we crack it, crack it. Yeah, I had it in my nice. I can't believe I figured it out. Because I was looking at it and I was like, no way you're gonna get out with 3x squareds. You're not gonna get it with 3x squareds. So you would actually have to divide the area into 3 parts. I was saying you would actually have to divide the area by 3 to end up with a third of the area, and a third of the area would be x squared plus 2x minus 2 over 3. And then big up.
I tell you, it's a genius, sir.
No, big up everybody. It was like a team effort. It was a team effort.
Oh, yeah.
Right. Serena, what do you think about this? Think it's cool?
Yeah.
You see, you said that you was thinking about this, but you didn't act on it.
Yeah, because it was after I already tried so much times, I just get fed up. I thought about it and I just didn't do it.
Well, next time, because I was on the same thing, and I was like, let me just move on to another question. I was like, wait, I have an idea. It might be far-fetched, but logically, it makes sense. So if it logically makes sense, then it should work, right? Yeah, you see what I'm saying?
Yeah.
If you know 1 plus 1 is 2, why would you not go ahead with saying 1 plus 1 is 2? Once everything makes sense, you should be fine. So let's recap what we did. So Serena, Caleb, Avinash, Zachary, pay attention. We're gonna run through the madness here, and you'll tell me if I lose you. Right. So, guys, we were seeing that when it was 3x squared, when you had 3x squared, that wasn't working out, right? There was no way we was gonna get 3 on the outside. Like if this is the final answer, there was no way we was gonna get 3. There was no way. So look what I did. I divided both sides by 3, right? So Zachary, I really need to tell me if you're confused, right? So tell me, Zachary, if you were to represent this graphically, like with diagrams, and this will be the total area of the shape.
Yes, sir.
Okay. If I divide the area by 3, right? So I divide the area by 3, wouldn't I be left with this?
Yes, sir.
Okay, so I didn't lose it yet, right? You with me so far?
Yes, sir.
Okay. So tell me, Zachary, x squared, isn't that literally just x by x?
Yep.
Okay, 2x, isn't that just 2 blocks of 1 by x?
Yes, sir.
Right? So I want to make a square. So I place 1 over here, and I place 1 over here. So this dimension would have been x plus 1, and this dimension would have been x plus 1. You with me so far?
Yes, sir.
Okay, Caleb, right? Tell me you're with me so far.
Yes, sir.
Okay, so Caleb, this area we find for here, is it the entire area or is it just a third of the entire area?
That's it.
Is that third of the entire area, right? Nice.
Yes, sir.
Did I understand that? So you understand that this dimension is x plus 1 and this dimension x plus 1. Right. Now, Avinash, is this a perfect square?
Nah, so you're missing 1.
I literally missing 1, right? And at the start, and that was missing minus 2 over 3 as well.
Yes, sir.
So I'll say minus 1 minus 2 over 3. Keep in mind, Avinash, this is not the entire area. This is a third of the entire area. So whatever we do, we'll have to multiply by 3 to find back the whole area. Yeah, so just keep that in mind, right? Keep that in mind. Keep that in mind. Avinash, minus 1 minus 2 over 3, that's minus 5 over 3. Tell me, is this the full area or is it a third of the area?
I saw a third, sir.
Right. So if you want to get back the whole thing, you'd have to multiply a third by what?
By 3.
Exactly. If you multiply everything by 3, the 3 gonna cancel off here and you're gonna get back f of x. On this side, the 3 is going to multiply by the x plus 1 squared. And Avinash, if I multiply this by 3, the 3 is gonna cancel off.
Yes, sir, and you'll just get left with the minus 5.
Right. I want to try another question and see if we could make it work using this technique. Are you curious? Everybody real quiet, so I can't tell. Can't tell if I'm curious.
I will say yes, sir, but like,
You don't know if I like, Serena, how are you feeling about it?
I want to try it again.
Like, you want to know if it will work with another question, and
Yeah.
I want to know that too. Zachary, you're not a bit curious? Like,
Yes, sir. A little bit.
you're not so curious.
Yes, sir. I'm curious, sir. I'm curious, yeah.
Right. Well, let me try another example, right? So we had have another question here. All right. Okay. Before we do it with the diagram, I want you all to attempt the question by yourself. Let me just get rid of this. Nice. Okay, so before we do the question using the graphical method, I would like you all to try this question. I'm going to give you all 6 minutes. Good luck. Right? So see if you can get the correct answer using the original method with H and K, and then I'll correct it and we'll see if it works with the diagram. We will see. Zachary, do you know the formula for H and K?
Yes, sir.
Okay, good. All right, Caleb, use whichever formula you feel confident with. Use any one. I don't take no horrors. Once it's correct, it's correct. There are not two
Yes,
ways.
sir.
There are multiple ways to do the same thing in maths. So you use whichever one you're comfortable with. Avinash, you remember what H, remember how to find H and K?
Yes, sir.
Okay, good. All right. Serena, I finished with B part one.
Yes, sir.
Okay, nice. What about B part two?
Not yet.
Not yet? Okay. Zachary, you finished with B part one?
Yes, sir.
Okay, Caleb, what about you?
Yes, sir.
All right. Avinash, what about you?
Yes, sir.
Okay, good. I'll go in on. I'll go in good then. Keep pushing. Oh, and Serena, if you speed run this thing, see if you could figure it out using a diagrammatic approach. Using the hacker just not come up with.
Okay, sir.
All right, guys. So after today, we should be 100% okay with completing the square. 100% okay. The other things we have to do, right? If we have enough time, I'll go through the quadratic formula and I'll go through the discriminant because you need to know about the discriminant, b squared minus 4ac. After that, you need to know how to deal with rational inequalities, and you need to know sum and product arrays. And that's it for quadratics. All right, so you will have a little over a minute remaining. See if I could lock in and finish the question. Or I could do it.
So
Tell me.
the minimum value is K, right?
Yes, that's how low the graph going down to. Yeah.
I,
Okay.
I finished, sir.
Okay, you got through it part three as well.
Yes, sir.
All right. But some me working.
Okay.
Before you start me working, do you write scrappy units?
Kinda.
Kind of scrappy or like
Well, like, you should understand.
okay, cool, cool. All right, guys. The time is up. How did we go? How was it? Caleb, I'm still waiting for the answer, waiting for a picture. Okay, Serena, you there?
Yes, sir.
Yeah, Serena, I didn't finish the diagrammatic approach, yeah? Remember, Serena, with the hacker came up with, you first split it up, you first divide it into an area for which x squared, for which it would just be x squared, right? Now, in this case, you had to divide by 4. So what you actually found for was a quarter of the area. So if you want to find the whole answer, you'd have to multiply x plus 1 squared minus 3 over 2 by what?
By 4.
Yeah, do that for me. Okay, Caleb, that wasn't a bad attempt, right? But is you wouldn't get full marks. We need to run through the proper working, right? Zachary, I didn't get an answer from you. Zachary and Avinash, I didn't get answers from you guys.
Oh, so we had to send you the picture.
Yes, yeah, there's somebody picture.
All
I
right.
have it in here, but me and if you want to understand, you had it.
That's okay. Send it, send it. I need to see I need to see all the attempts in it at least.
Hold on, sir.
Okay, so let me jump straight into it, right? So Caleb, part 1. What kind of expression is this? What would you call that? Starts with Q.
Is it?
First things first, what kind of expression is what kind of expression is this? It starts with Q,
Quadratic.
right? And it's in the form ax squared plus bx plus c, right? If that is the case,
Oh,
could you tell me what A is,
is first
right? B is equal to,
negative. We'll take negative 8 here.
right? And C is equal to,
Negative 2.
right? Put down the formula for H. H is equal to B over 2A,
Yes.
right? So H would be equal to B. B is minus 8, right? A is 4. So we end up with minus 8 all over 8. What's negative 8 over 8?
Negative 1.
Perfect. Now K, I'm going to use the other formula, but you should get the same answer, right? C
Yes, sir.
minus B squared over 4A, right? So K would be equal to C. Now C is minus 2 minus B. Here, what? You need to put a minus 8 in brackets. So put a minus 8 in brackets squared all over 4 by A. Now A is 4, so I put 4 by 4, right? And
Yes,
then
sir.
gonna put back minus 2, put back the minus sign. What is minus 8 squared?
Is it?
What is minus 8 squared?
Oh, man, 16 is good.
Say that again.
8. 50.
8 negative 8 by negative 8.
64.
Yes, 64, right? Negative 8 squared is positive 64. And where's 4 by 4?
16 is it?
Right. Don't get too reliant on the Casio here because for the maths paper one, you don't get to use a calculator.
Yes, sir.
Right? So you're supposed to, like, when I ask you questions like minus 8 squared, you're supposed to have on luck. right? But minus 8 by minus 8. You have a negative and a negative, so the final answer is positive. Then you have 8 by 8. 8 by 8 is 64, positive 64. You had a hard thing on lock, right? Okay. Then we have 64 over 16. How much times 16 could go into 64?
Four times.
Right? What is minus 2 minus 4?
-2.
No, minus 6. Caleb, let me show you a way to understand this, right? Now, imagine you think of negatives as taking. You take money from somebody. Caleb, I hope you don't tax nobody, do you?
Nah, sir.
It take a little while to answer that, that kind of sound suspicious. Unless your friend's giving you money, because I know it's Christmas time,
Nah, sir.
right? So, okay, Caleb, let me just say you take $2 from your partner, right? You take $2.
Yes, sir.
How much you owe them if you take $2?
$2.
Okay. Let me just say you take $4 more. How much you owe them now?
6.
Right. So -6. -6. Understand?
Yes, sir.
-4 is -6. Right. So Caleb, you didn't finish the question. I see that you're fine for H and you're fine for K, but you did not.
Yeah. I missed on the other part.
You're supposed to write it in that form. So let
Yeah.
me answer that. So they wanted it in the form A, open bracket, X plus H squared plus K. Now, can you remind me what was A?
A is 4.
All right, so I'm going to put over here. All right, so A is 4. Okay, what is H?
H is -1.
Right, so I'm going to replace H with -1, so squared. Right,
Right.
I'm going to replace K with what?
-6.
Right. How much of you all got this answer? Avinash, I still didn't get anything from you.
Yeah, no. Yeah. I get that also.
Okay, I'm not gonna properly believe you unless I see it. Yeah,
I know, I know, I had the crop out. My foot doesn't need to check.
that is okay.
Yes, sir, I get the answer.
Okay, great. Right, so that was the answer there. Nice. Now, part 2. State the minimum value of f of x. Now, the minimum value is always given by key, right? Minimum or maximum value is always equal to key. Now, in this case, since the coefficient of x squared is positive, we have a minimum, right? So the minimum value would just be equal to what? What is k equal to in this question?
-6.
-6. Now, I see that someone do the wrong thing for part 3, right? Caleb, I think you do the wrong thing. Anytime they ask you to state the value of x for which f of x is a minimum, the answer for that is just simply -h, right? So I'll show you why just now, because you're probably wondering why.
But I didn't get it. I didn't really do part. You get somewhere because it was like negative age, but like age was already a negative. So like kind of
Oh, no.
confused.
If it, you had to put back on, like, I'll show you what happened, right? I'll show you. So value of x for which minimum or maximum occurs. Anytime they ask that, the answer is -h. In this case, we would have a minimum value. So we want to find the value of x that gives us the minimum value. Right? So value of x, right? For which f of x is minimum. Okay, and it's equal to -h, right, guys? It's -h. So that'll be equal to minus open bracket. What was h, guys?
-1, 2.
Right, so it's minus h, guys. So you're not going to write -1. It's minus, right? So it's minus, you put back the minus, and then you're going to plug in what h was. So we found h to be -1. So I'll put that in brackets, right? So minus by -1, that'll be 1. Right, so that's your answer, 1. Right, so you would say x is equal to 1. Caleb, you want me to explain that to you, because I feel like that confused you. Caleb, that confused you a little bit.
So he isn't in the meeting.
Oh, he isn't in the meeting. Okay, that's weird.
So check that in. Getting Ariel's crappy, but
Let's see here. Okay. Yeah, you need to work on how you're writing your working, because that is very scrappy. So you're supposed to write the formula for h first. You're not supposed to plug it in one time. So it's like take it in steps. Right? So you're supposed to say h is equal to, and I'm not seeing the equal sign. You're supposed to say h is equal to b over 2a, and you're supposed to write the formula for k as well. But you got the correct value for h and k, right? Avinash, check this, right? You was probably confused about this part. So they're saying plus h, right? I see you right, plus -1. Let me make it simple for you, Avinash. You see this plus 8? You see that plus h? Whatever you get for h, just replace it with it. So we got h to be -1. So replace positive h, what do we get for h? So -1. You see this plus k? That means to replace k with whatever you get. So we get -6, replace our plus k with -6. That's it. Right? So you didn't do a bad job, right? You didn't do a bad job. Now, Caleb, I see you join back. You all right?
Yes, sir.
Okay, now, Caleb, I see that part 3 kind of confuse you a little bit.
Yes, sir.
You didn't get the correct answer. So let me just explain something, right?
Yes.
Guys, just reminder, if I want to figure out the minimum or the maximum turning point, how would I figure that out? How would I find the maximum or the minimum turning point? It'll be given by what?
Key.
Minus h,
Key.
comma, key. Right? And minus h would correspond to a x value, and k would correspond to a what value, Caleb? Since it's
Y value.
great. Now, our graph, the coefficient of x squared was positive. So we had a minimum graph. We had a minimum graph, right? Keep that in mind. So we would actually have a minimum turning point. We would have a minimum turning point. All right, so guys, let's calculate the minimum turning point. So it's minus h. What did we find h to be, guys?
-1.
Minus,
Well, yes, sir.
yeah. And what do we find k to be?
-6.
All right. So our point will be what? Where's -1?
1
What is, just -6.
-6. Yes.
Right. So guys, I am going to do a very rough sketch of the graph. And it will make so much sense, guys. Now, guys, will this graph look like that or like that? 1 or 2?
1.
Yeah, it would look like
So
1.
1.
Yes, it would look like 1. So that's y and that's x. Cool. Now, we agreed that this will be the x value and this will be the y value. So let's try to locate our point. So x is +1. Where do you think that would be? Do you think it'd be over here? Over here.
On the number 2, sir.
On the right-hand side, correct. So we could say that 1 is over here. And then y is -6. So we're going to go on the y-axis. Would that be upwards or downwards?
Downwards.
Right. -6. We can say that -6 is right over here. Right? So this point represents the lowest point of the graph. And that point would be 1, -6. So yeah, everything is going to make sense. Trust me. Oh, and I have a question, guys. I'm curious. How would we figure out the y-intercept? Could somebody remind me how, if they asked me to find the y-intercept, how would I do that?
So it plugs you into the equation.
Yeah.
Right, and I would get -2. Fun fact, the y-intercept is always the c value, right? Watch, ax squared plus bx plus c. And the reason for this is because anything with x in it, if you are putting 0 into it, right? And this whole thing just gone into 0, and anything with x gone into 0.
Yes, sir.
Yeah, so every single time the y-intercept is just simply the c value. So the c value in this question would be -2, and -2 would be like, I just estimated, and it's a sketch. Call that -2. All right, so now we're going to draw the graph. Did I confuse anybody so far?
No, sir.
Okay, that's good. All right, are you okay with our graph, right?
Yes, sir.
Okay, good. Tell me, guys, what is the minimum value for the function? What's the minimum value?
-6.
You can see that for sure.
Yes, sir.
You can see that for sure. This is the minimum value, right? Minimum value. All right. Caleb, you're going to see how it's making sense now. If this is the minimum value, what gave us -6? What value for x gave me -6?
K.
Now look at the point. What
Oh.
value for x gave me -6? What value of x?
1, sir.
Exactly, 1. So in other words, when x is equal to 1, what is y?
-6.
Exactly. Right? So I hope it makes perfect sense. So this is the value of x for which the minimum occurs. I mean, actually understand that?
Yes, sir.
Okay, and guys, if I wanted to figure out the axis of symmetry, what would the equation for the axis of symmetry be for this question?
1, sir.
One.
Probably
Are they wrong? Well, close, but they're wrong. Remember, equation, if I'm talking about an equation, it must be equal to something. So what is equal to 1?
X is equal to 1, sir.
Yes, x is equal to 1 because it would be a line passing through 1 on the x-axis. So x is equal to 1. Great. All right. So I hope we understand the entirety of the question. So in part 2, they ask you for the minimum value, right? The minimum value would just be the k value. That's how low your graph going. And then in the third part, they asked us to figure out the value of x for which it happened, right? So that would just be -h, right? And in this case, we found out to be 1. So is everybody okay?
Yes, sir.
Okay,
Yes,
great.
sir.
Now let's try to do this question graphically. Do I have any volunteers? Any other brave in class?
Good.
I hear somebody for a moment there. I heard somebody. Caleb, that was you? Or Zachary, that was you?
I was, but I don't know if I could do it.
Well, you never know until you try. Let me give it a try. Okay. So first things first, Caleb. What is the number in front of x squared?
4.
Okay, we can't do it if it's 4. We can only do it if it's 1x squared. So we think I should do throughout.
Divided by 4.
Exactly, I should divide it by 4. So we're gonna end up with f of x over 4.
Yes, sir.
What is 4x squared over 4?
X squared
Right, where is minus 8x over 4?
minus 2x.
Yeah, I don't know why I say 4. Minus 2x. And where is minus 2 divided by 4?
Minus 2 over 4.
That'll be minus a half, right?
Oh, yes, sir.
Yeah, think about it. 2 is half of 4. Nice. So now we can see that this shape is made up of, well, this might be a little tricky, but we'll go with it, right? Let me see how we'll go. And the answer for this is x minus, we'll see, right? Caleb, x squared. Isn't x squared? Let me just change this to, give me a moment. Let me just change it to the grid. Squared paper. Okay, nice. X squared, isn't x squared x by x?
Yes, sir.
Okay, x by x. All right. Okay. Now, this is where it's a little bit weirder. Tell me, Caleb, if I wanted to end up, now this can happen in real life, eh? You can't get negative lengths, but we say it like hypothetically speaking. Tell me, Caleb, if I wanted to get minus 2x, wouldn't that just be 2 blocks? That would be minus x each.
Yes, sir.
Okay, so what would the top dimension be then?
1.
No, it would be minus 1,
Negative 1.
right? And this dimension would be?
Negative 1.
No. What would I need to multiply by minus 1?
Oh,
Minus
X. Sir.
x. Okay, right? Okay, you with me so far?
Yes, sir.
How much minus x's does it have?
2.
Right, so I'm gonna make another one of this. Right, and we know it's minus a half. So let's get cracking. Right? I'm going to put on the square here. I put on the square. And I'm going to take one of these. Going to place it over here. No, I couldn't place it like this. Right, like this. The other one, we think I should place the other one.
Below the other rectangle.
Nah, I mean a square, like this.
Yes, sir.
Okay. Right. This dimension here is x. What's this dimension?
Negative 1.
Right, and this dimension.
Negative 1.
Okay. And we missing a piece, right? And you can see that we missing a
Yes,
piece.
sir.
Okay, this dimension here is negative 1, and this dimension here is negative 1. So we missing what? What is negative 1 by negative 1?
Negative 2.
Nah. Negative 1 by negative 1 is
Oh,
positive,
negative. Well, positive 1.
right? So if we look at the dimension, we have x minus 1 here. And we have x minus 1. Did we successfully make a square?
Yes.
Yeah, we did. If you make a square, then the two sides had to be equal. So we good. We good. Right? Now, is this a perfect square?
Yes, sir.
No, it's not a perfect square. You're missing one. Remember? You're missing one.
Oh, I thought it. Well, no, sir.
It's not a perfect square. So here what we're gonna do, right? This is what we're gonna do. If it was a perfect square, then the area would be x minus 1 squared. However, Caleb, and we missing one.
Yes, sir.
If you're missing one, would you say +1 or -1? If you're missing one,
-1.
it will say -1. And from the start, we was missing what already?
-1.5.
It was missing a half, right? So -1/2. Okay. Let's see how this is going to pan out. What is -1 -1/2?
Can you repeat, sir?
What is -1 -1/2?
-1. Minus.
I could hear you plugging it into your Casio.
Yes, sir.
You don't need a Casio for that watch.
-1. Well, -1/2, sir.
Now, what the answer is a mixed number. I mean, not a mixed number, as an improper fraction. You know how to convert it to an improper fraction?
Nah, sir.
Okay, let me get my Casio calculator real quick. Give me a second. I do have a virtual Casio. I'll let you hear Mariel talking about Casio. I overlove Casio too bad.
Yes, sir.
I started a Casio watch collection. I really love Casio. Casio is the best. Is the calculator I have?
Yes, sir.
Okay, so this is what we're going to do, right? So -1, -1/2, press equal. Okay, if you're not getting -3/2, you need to press Shift S to D.
I did after putting the second minus, I make a mistake and put -1. That way. So I get -3/2.
Okay, good. Okay, and if you want to get the full area now, remember we did divide it by 4. If you want to get the full area, what are you going to do next?
Multiply by 4.
You're going to multiply it by 4. Everything by 4. So if I multiply the left-hand side by 4,
Is 4 open bracket x take away 1 squared.
right? And what is -3/2 by 4? The 2 into 2
4
is 1, 2 into 4 is 2, -3/2 is?
-6.
Okay, do we get back the same answer?
Yes, sir.
Big up ourselves. Kill up, you're the boss, you're the boss. All right. We get it. You feeling good?
Yes, sir.
Nice. Right, so I'm glad to hear everybody understand this. Right. Yeah. So I'm glad to hear everybody understand this. Are you feeling okay with completing this square?
Yes, sir.
Yes, sir.
Yes,
Okay,
sir.
okay, nice. Nice. Serena, apparently it does work. It does work for any shape. Yeah. You probably say something bad in here. I know you just talk a little quiet, as in mic or something. Yeah. Serena, you think if he was confident and he kept going in the direction he was thinking, you think he'd have figure out this?
Probably, yeah.
I think so. Think so. Right? Serena, if you want, I could give you a challenge, like an even harder challenge to crack. You
Sure.
think you're up for it?
Yeah.
Okay, but this challenge. Okay, so you see this method here?
Yes, sir.
You could generalize it. And when I say what I mean by that is instead of using numbers, you could use letters. And in doing that, you'll eventually end up with if everything works out, you'll end up with A open bracket X plus B over 2A, right? Plus C minus B squared over 4A. It's a really tough cookie to crack, but I think you're the person for it. Essentially, I'm going to give you a diagram and I'm going to ask you to make a generalized formula. It's the same method, right? It's the same method, but instead of using numbers, you're going to use letters. And at the end, you should derive h and k. You should be able to derive it. So I will formulate the question and I'll give you it. I'll send it in group chat for anybody that's crazy enough to also do it. All right, but I want to challenge your smart brain. I don't want to waste our potential. So yeah. Caleb and Zachary and Avinash, are they have any questions? Like, they have anything or they want to clear up? Like anything at all? Or they know I don't mind clearing up anything? Or they just tell me?
That's like good.
Nasty.
That's
Okay.
everything looking good.
So like if I give all like a flash quiz, like, or they should be giving me like the correct answer then. That's all they're saying.
Yes, sir.
Okay. What's the formula for H?
B over 2A.
All right. What's the formula for K?
C take away B squared over 4A.
What's the other formula for K?
4AC take away B squared over 4A.
Hey boy, Caleb, like a semi-automatic rifle. Hey. All right. Avinash, what is the general form of a quadratic?
A x squared plus bx plus c.
Right. If A is more than 0, is a maximum or a minimum graph?
Minimum.
Right. Minimum. Great. Because if it's more than 0, means it's positive and it's smiling. What if A is less than 0? Maximum or minimum?
Maximum.
Right? Because if it's negative, it means you're sad. Oddly enough, this looking like 2 eyes and this looking like a nose. You see what I'm talking about? This looking like 2 eyes and this looking like a nose.
Yes. Look like a sad face. That's my
Yeah.
face.
Yeah. Okay, so we know what this is. Great. We know that this is H, this is K. Nice. If I wanted to figure out the maximum or the minimum turning point, what would give me that? What would give me the maximum or the minimum turning point?
So minus H, comma K.
Minus, oh yeah.
Right. If I wanted to figure out the axis of symmetry, that would be x is equal to
Minus H.
great. If I wanted to figure out the maximum or the minimum value of f of x, that would be equal to what?
Yeah.
That would be key, right? Remember, k is the y value. That's telling you how high or low you're going, right? And what value of x would give the maximum or minimum? Tell me, guys, what value of x would give the maximum?
Minus H.
Great. Minus. Wait, well, bad. Right? Great. I don't really think I have anything else to ask. If I want to figure out the y-intercept, how would I do that?
The C value, well,
Yeah, just your c value. Yeah, correct. Just your c value. Or I think you was gonna say just put x is equal to 0. That's correct.
yeah.
Now, Caleb and Zachary, are they would have missed out the part where I showed the class how to solve it, how to solve the roots or the x-intercept using using the complete square form. Essentially, if you want to find the x-intercepts, at the x-intercepts, y is equal to 0, or f of x is equal to 0. So you would have let the whole thing be equal to 0, and you'd have make x the subject. So I could go through the notes, and if you have anything that confusing all you, just let me know. I will send the prior recordings as well. Before you all leave, I just want to do some factorization exercises with you guys really, really fast. Are you all familiar with the AC method?
NASA.
Okay. Well, I'll give a quick recap on it, right? So there are 2 types of quadratics you would have to factorize. A simple trinomial, don't let trinomial confuse you. Tri just means 3 terms, right? Zachary, and all quadratics would have 3 terms in it, A, B, and C. A
Yes,
x
sir.
squared. Right. So it's a trinomial. Binomial would be 2 terms. If you see trinomial, 3 terms. Okay. A simple trinomial is when A is equal to 1. Let me give you an example. Suppose you had x squared plus 12x plus 27. What is the coefficient of x squared there?
1.
1. Avinash, remember how to factorize something like this?
Yes, sir.
Okay, so
X.
Avinash, first things first, how would you multiply to get back x squared? What by what is x squared?
X by X.
Right. Then you're going to look at 27. How could you multiply to get 27 and add to give you 12?
That was 9 and 3.
All right,
Equals
9
1.
and 3. That's it. That's simple. That's simple to factorize a quadratic. If it's a simple trinomial, it's extremely simple. Right? So Zachary and Caleb will go out for it, right? If A is 1, it's real simple. All you're gonna do is you're going to look at the last term. How could you multiply to get 27, but also add to get the middle term? And if you multiply 9 by 3, you'll get back 27.
Yes, sir.
And if you add 9 and 3, aren't you gonna get back 12?
Yes, sir.
So you can put the plus 9 and the plus 3 anyway. You can say plus 3 plus 9. Anyone is fine. All right, but that's a quick example there. Let me go on to the next one. Suppose it was, I'm gonna raise these stakes a bit. What if it was x squared minus 3x minus 18? Zachary, let's give it a crack, right? First things first, is it a simple trinomial?
Yes, sir.
Yeah, because A is equal to 1. Right. So to get back x squared, that's just x by x, put x by x there. We're gonna look at the last term. How could you multiply to get minus 18, but add to get minus 3? Think to yourself, how could you multiply to get minus 18?
6 by 3, sir.
Okay, 6 by 3 would give you positive 18. It wouldn't give you negative 18.
-6.
Yes. Zachary, negative 6 by positive 3 would give you negative 18. And if you add negative 6 and 3, what are you going to get?
Negative 3, sir.
Right, so that's the correct answer. So I'll put the negative 6 here and the plus 3 over there. That's it. Let me do one more. Right, really, really fast. Right. What about if we had x squared plus 8x plus 15? Right? Avinash, tell me. X squared, we know that'll be x by x. We're gonna look at
Yes,
15.
sir.
How could I multiply to get 15 but add to get 8?
3 and 5 or 5 and 3.
All right, plus 3 plus 5. That's simple. It's that simple to factorize quadratics, right? Let me just give you a quick introduction as to what you would do if it's not a simple trinomial. Right? Not simple. If it's not a simple trinomial, it means that A is not equal to 1. Let me look at a simple example. So suppose we had something like 2x squared plus 13x plus 15. What you're going to do is you're going to multiply the A term by the C term, right? Zachary, what's A by C in this case?
Just say
A by C is
30, sir.
30, right? The next thing you're going to do, you're going to think of two numbers that can multiply to give you 30, but add to give you what? Take a guess.
10 and 3, sir.
10 and 3, bam. Next thing you're going to do, right? You're going to take a middle term and you're going to write it as a sum of two x terms. So you can write it as plus 10x, right? And plus 3x, right? Then plus 15. Imagine you have a line in the middle. You're going to recursively factorize each side. So you're going to factorize each side. And then we're going to factorize by grouping. So Zachary, imagine I had like a imaginary wall there, right? Let's factorize this side. You see anything in common between 2x squared and 10x?
Yes, sir.
You see it in common,
2x, sir.
right? If I pull out 2x from 2x squared, what I write
Plus 5.
x plus 5, right? Okay, let's look at the other side. What are you seeing in common between 3x and 15?
3, sir.
Seeing 3, right? So I'll put x plus 5. Notice, and you see x plus 5 here and x plus 5 there?
Yep.
So I can pull out that. If I pull out that, all right, 2x here and plus 3 over here. Understand that?
Yes, sir.
And that's how you would do the AC method, right? Caleb, you could do one with me. Avinash, you could do one with me, and I'll be it for class. Right?
Yes, sir.
Okay. Caleb, we're gonna tray into the water, right? Apologize in advance. 3x squared minus 12x minus 15. Remember the first step, Avinash? I mean, Zachary? I'm saying Zachary. Caleb. Remember the first step?
Divided by C.
A by C, right? Where's A?
3,
Where's C?
15, negative 15,
What would 3 by minus 15 be?
45, minus 45.
Right? How could you multiply to get minus 45 but add to get minus 12?
Minus 5 and 9.
Nah, no minus 5 and 9. Minus 5. If you add minus 5 and 9, you're gonna get 4. You're not gonna get minus 12.
Yeah.
Right. Think, Caleb. Figure out what the negative, right? Tell me, Caleb. How could you multiply to get 45?
9 by 5.
Okay, but if you add 9 and 5 or something, you wouldn't get 12. That can work.
It wouldn't get us. That's, I don't know.
All right.
The
Sorry, now
minus 9.
nah, anything with 9 wouldn't work. Sorry, now I want to tell them. Yeah. Serena, you seen anything? Okay, if Serena saying something I can't hear. Zachary, think you can figure it out?
I'm trying to think of something, sir.
Everybody trying to think of something. I tell you, Caleb, I cannot try into the water with this one. Let me show you an alternative way you could do it, right? So, like, watch this, guys. To get 45, and you could say 9
Yes,
by 5.
Serena, still something in the chat, sir.
Let's see, wait, we have any chats.
She
Yes.
said 3 and negative 15.
Yes, that is correct. That is correct. Let me show you something, right? If anytime you're having trouble coming up with possible factors, is what you could do. So 9 is 3 by 3. Look how you could do, right? So for 45, the prime factors in this case will be 9 and 5, right? And then 9 could break up into 3 by 3. You can't break it up anymore. Are you with me?
Yes, sir.
Check
Yes,
this,
sir.
right? So we're gonna circle 3, right? And then you're gonna multiply 3 and 5. Just like that, you got some other factors of 45. And 3 by 15 is 45.
Yes, sir.
So you could use this method anytime you want to come up with other factors. It works for, right? So 3 and 15 were the correct ones to use. Now, guys, are they want to get a positive answer in the middle or a negative answer in the middle?
I'm negative.
So we think you should put the negative by the small number or by the big number?
Big,
Right, because you want to get a negative answer. You want the big number to be negative. So the negative will dominate the positive, right? All right.
Yes.
So what we're gonna do now, we're gonna take that term in the middle and we're gonna split it. Right? Split in the middle. Anybody know that so? Right? But Caleb, to get minus 12x, I could write plus 3x what? Plus 3x what?
See?
So how this method does work, right? You find the factors and then you take the term in the middle and you split it.
Yeah.
So you look at the previous example, 13x. We split it into 10x and 3x.
Yes, sir.
Right, so in this example, we have 3 and minus 15. So we're going to split up minus 12x into 3x. What?
9.
Nah. So 3x, positive 3x. You can do it kilo. So I put the 3 by the x here.
Yes.
And then what I'll do here.
Mm.
All right, I'm going to help you out a little bit. You're going to put minus 15x here.
Okay.
And if you're confused by that, I want you to put 3 minus 15 into your calculator. Which 3 minus 15?
Negative 12.
Right, so all we did was we just wrote minus 12 as
Yes.
3x minus 15x, right? Then I'm going to put minus 15 here. You're going to draw an imaginary line in the middle, and you're going to factorize on either side. So, Caleb, you seen anything in common between 3x squared and 3x?
Yes, sir.
What you seeing in common?
X and 3. 3
Right,
and
so
X.
I pull out 3x. If I
Yes.
pull out 3x from 3x squared, what would I write here?
X
Right? Plus what?
plus.
Oh, all right. I already answer. Sorry. I just do that sometimes. And it's like out of habit. I don't know. Sorry. But it's 1. Because 3x by 1 is 3x, yeah?
Yes, sir.
Yeah. Let's do the other half now. So what you notice in common between minus 15x and minus 15,
15
right? And not just 15, and you notice negative,
minus 15. Yes, sir.
right? If I pull out minus 15 from minus 15x, what would I write on the inside?
X
Right? What would I write on the inside if I pull out?
minus 1.
Nah, not minus 1.
Oh, positive 1 because I did 2 negative.
Yes. I
Yes.
take out the negative now. Right? Notice you're seeing x plus 1 here and you're seeing x plus 1 here. What I mean
Yes.
is we could pull out the x plus 1 now. If I pull out
Yes.
the x plus 1, what I write on the inside?
Um, 3 X take away 15.
Yes. Yes, because you took out the x plus 1 here, so that's just 3x, and you took out the x plus 1 here, so that's just minus 15. Great.
Yes.
Right? Is a boss. So now you know how to factorize the 2 types of quadratics. You shouldn't, if it's coming at us, you
Yes,
should
sir.
be able to handle it like a boss. Right? Avinash, your turn. Right? I didn't forget you. You can't escape. Right, one more question for you, and that is it. Right, let me just get on our page. Okay, Avinash, I gone. Sorry in advance. But I think you'll get
Like,
it. I think you'll get it. 8x squared plus 19x plus 6. Sorry. Okay,
40.
what's the first step?
Okay, well, so it'll be, well, first you're thinking 8 times, will be 8 times C, so 48.
Right, 48.
Mhm.
And if any of you can figure it out, do it and submit on via WhatsApp. Right? Don't blurt it out. Tell me what's next, Avinash?
Then you find two that the multiply make 48, but also add to make 19.
Correct.
Nah, 12 and 4 won't work.
Okay, let me show you the trick, right? So we was telling for 48,
I was saying 12 and 4.
12 on 4, right? Okay. I can write 12 as what?
6 and 6.
And I can write 6 as
2. And 6 as 3 and 3. 6 and 2, oh God. 3 and 2. My bad, sir.
and I can write 4 as 2 by 2, right?
2 by 2.
Okay, if you select 3, then I can write that as 3 by 2 by 2 by 2, right? 2 by 2 is 4, 4 by 2 is 8, 8 by 2 is 16. 3 and 16.
3 and 16.
Would that work?
Yes, sir.
Yeah, that would work. So this little hack Ashtray is like another goated hack.
Unless the number really big.
Huh?
I said unless the number really big, then it might not work.
Yeah, it will always work. This will always work. This hack Ashtray here will always work.
So you figure this out.
Just figure it out, like just by doing real maths. I just figure it out eventually. Like when most of your life is maths, you just kind of figure out some hacks.
Okay.
Most of my life is maths. Just be doing maths all the time. We'll get away from it. All right. So yeah, 3 and 16. So tell me what's in the next line.
There'll be 8x squared plus 3x plus 16 plus 6.
Great. What am I going to do in the next line?
Then you have to factorize them out.
Okay, let me. Curious to see how you're going to do this one. Yeah.
Watching this answer.
What does have in common between 8x and 3x?
The x.
Right. If I factor out x, what am I write on the inside?
X plus 8.
No. No.
What
would if I pull out x from 8x squared?
8x.
Right. If I pull out x from 3x.
3 plus
right.
3.
Let's do the other side now. You see anything in common between 16 and 6?
6.
No. Nah.
No.
Don't tell me that. We're looking at common factors. So is there a number that can be to both 16 and 6?
No.
Yeah, there is a number. Think. 16 and 6 are both factors of, they're both multiples of 2. Both multiples of 2. So 2 would be a factor. So if I pull out
2. It'll be wait.
Okay, what by 2 will give you back 16x?
6. No.
Zach answer.
8.
Okay, now we not finish this one. You had your chance. I know you're excited, but wait. Right? Yeah, 8x, right? And
8x, yeah.
plus what?
Plus 3.
Right. You see an 8x plus 3 here and 8x plus 3 here. That means you could do what?
Pull them out.
Right. And what would I write on the inside?
X plus 2.
Great job. Yeah, that's what you had in mind?
Yes, sir.
Nice. So yeah, that's it for class today. Caleb and Zachary, how the final first class was?
It was good, sir.
It was good too.
Good to hear. That's good to hear. It wasn't boring, right? I'll keep you honest, man. I'll keep you honest.
Nothing.
I'm like
Nothing.
I'm like a tough heart. It's like tell me if it was boring. I totally wouldn't cry after class. And I totally wouldn't play some juice bowl and totes. Totally wouldn't do that. But I'm glad to hear you enjoy it, man. I'm glad to hear that. Uh I will send some homework on the chat. Right. Let's see.
So since let me tell you a joke well my friend do after that maths when he had that yesterday. So my teacher make a joke in a time in school and say all the minimum graphers look like me. He say me. And so it's called my Abby in school. So my friend write down on his scrap paper what like he example workings before he write it down in the actual test paper. When he bring the paper and show me he have the minimum thing as minimum equal to Abby.
What? I don't get that. Why does he not use the minimum?
I don't know. He just say that. And he said I was the minimum.
That's weird. Unless just saying that, they use like the unless like they're like roasting you, which would be very mean. They would be saying that is like the minimum, like the lowest.
No, the guys look at the minimum graph. So the minimum graph look like it's smiling.
Oh, and you always smiling.
I guess so.
It's something like you're smiling right now. It's something like you're smiling.
So he bring the paper for me after that and I watched it and I said, boy.
Yeah, you sound like a very smiley in the video.
Depends.
Zachary gonna reply with a heartbreak emoji. Wait. I really look like like a ChatGPT response. Like when you put it on dark mode, that's what ChatGPT does look. But no, type that. Okay, let me give you the next question. Since you enjoy the question, I find it easy, Honestly, it's an easy 10 marks. I think it's an easy 10 marks, to be honest. I think everybody here could get our 10 marks. Yeah. By the way, guys, let's saw the December schedule, right?
Yes, sir.
Okay,
Yes,
good.
sir.
Nice. Right. During December, I might do a 48-hour continuous marathon, like no sleep. It's gonna be doing mass for 48 hours. If I do it now, I'll let you know. Or I could like chip it, like come online like for an hour or something and then bust out. But I'll let you know. I'll let you know if I do it now. Right? If I do it now, I'll do some hard maths and physics too. But I just can't be there only live for 48 hours. So the support will be good. So they could like come and check me a little bit. Yeah,
You
try.
run anything? You actually just like have it on TikTok.
Well, I go have a Zoom meeting, so I could join any Zoom meeting.
Ah.
Yeah. The goal is 72 hours. Continuous 72 hours. That's the goal.
Please, nah.
Yeah. That's it. I think I could make it. I think I could make it.
I believe you.
After 72 hours, so that might be a bit much. I might be pushing it. Yeah.
So you have be a man that like coffee then.
I don't really drink coffee. When I do them lives, I don't do coffee. I don't drink coffee much, to be honest. The adrenaline, man, the adrenaline, it just be pumping. I just be like very livid. Doesn't feel like sleeping. Yeah, I just crazy, Avinash. I just crazy. That's what it is. Yeah.
It's alright.
Like when I was doing the 24-hour live, I drink one monster. That was it for the entire 24 hours.
It's the way you're pushing it this time then.
Yeah, boy. Right, but anyways, Zachary and Caleb, it was nice meeting all you. Asho, Avinash, and Serena also enjoyed your presence. Yeah.
Yes, sir.
All right, but I hope you have a blessed night. Later, guys. Take
You
care.
too, sir.
Good night.
Sir.